let's get programming. So first of all, best bet is to create a variable with the sides in it. So we'll call this one sides. Left, right, top, bottom, oops, left, no wait, front, back, okay, and then we want the output to be at the bottom, don't we? So local output, output side, really, surely, output side. Now, common practice in programming is if it's not a variable, so if you're only ever going to get from a variable, so here we've got output side there. If we're never actually going to change it during the course of the program, except for at the very top, you write it in caps. So that means you know that it's called a constant, which means it's a constant variable or a constant value that you never change. So you can always rely on it. So we want our output to be bottom. Okay. So what code should we go for? Like, for the sake of this, let's go for an easy code to remember. So code equals, let's say 1973, the year Bunce was born. Not really. Let's figure out what tones we want buttons to make when pushing. So let's call it button push. Probably should give it a better name, but I can't be bothered right now. Equals 9, so that's the tone of 9, which is like the 9th from 0 on the note block. So local. Let's create a combination. So when you get it right, it should probably go like doo-ding, something like that. So let's make a combo. So say success equals 11, 13, and then let's do the same for fail. Oops, fail, and that should go the opposite way. That should go doo-doo. So 4, 5. That should be pretty cool. So let's remember how the door. So let's I'll see if I can make this one computer handle both doors because it's already got all the cables plugged into it, hasn't it? So let's say that let's create a variable called. We'll call this one the code door. And we need to know whether it's open or not, so we'll remember that. Code.open equals. Do we need to know if it's open? Well, we'll do it for now, and if we don't use it, we'll throw it away. So code.open is this, and then what I'm going to do is I'm going to create a table to store its properties in. So this is pretty simple. So we'll create. So we can say code door, and then this, and then our equals, and then this means it's a table. So that put those two curly brackets. I mean, it's a table, just like the same up there. If you've watched the computer craft stuff, you already know all this stuff. So there we go, and then we'll say code door dot close, and because this is Lua, this is perfectly allowed. So all you need to do is say dot means I'm making a variable on code door called close, or in code door called close, and we'll set what color it is to close, what color cable it is, which is colors dot black to close, and then we'll make one for open, so it's white to open, and again they're in caps because I don't want to change them. And how many does it take? 4 to close it. So code door dot pulses takes 4 pulses to close the door. Boxes to open or close the door. So pulses is 4. And then let's quickly do one for the other door as well. So pass door open equals false because it's currently closed. Local, by the way, is it means that the variable is not accessible to anything outside of this object. And in the case of like functions, it means the variable goes away after the function's finished. It's good practice to just write local in front of most of your variables. So false, we'll do another one. So pass door equals it's a table, and pass, let's go door dot open equals colors dot red. I think we'll say yes for now. Pass red. If it doesn't open, if it opens when it should close, then we'll know. Oh, I've got this the wrong way around. Green is close. Okay, and then pass underscore door dot pulses. And I think that's 4 as well. So we'll say 4 for that. Right. So let's make a variable to. So now we've got to start thinking about how we're going to show things on the screen. So, because we've got the buttons, obviously we want it so that when you touch a button it changes colour. Because that's, you know, why wouldn't you want that? So, I'm thinking that we should create a list of things to draw. So we'll create, so we'll say local draw list equals, it's empty to begin with. And then we'll have to know when to draw the list. So you wouldn't want to draw it every frame because a lot of the time nothing changes, does it? So whenever we push a button, we do want it to change because we want to change the color. And whenever the color changes back, we want to change it. So we'll say local. So we'll add a variable on the draw list called invalid. Invalid, and that should equal false for now because there's nothing on it, so it can't be invalid. So what we do is anytime we want it to redraw it, we set invalid to true, and then that forces a redraw. So now the other thing is how we're going to know when we've clicked on something. So how will we know when the player has clicked on something on the screen? So the easiest way to do that is to create a lookup table of all the buttons on the screen, and I'll show you how to do that. So we'll call that one click list, I think. So click list. List. That equals that. Right. Obviously we need a monitor, so local output, that's the monitor. That's where to output the video to. And then local, so there's 4 buttons, four what's it's in the code, isn't there? 4 characters in the code, so we'll say, we'll need to count how many buttons have been pushed, so count equals 0 to begin with. And we'll need to keep a running sort of thing of the code so far, so what buttons they've pushed. So we'll call that combo, and it's empty for now, and it's a string because it's a lot easier. So combo, and then let's make sure that we remember what color the background is. So look, current color equals colors dot black. Okay, so I reckon that's that. So that's all the variables I think we'll need. So let's get started in the main function. So let me just have a think. So we'll say, right, so local function, I always call it main, but you don't have to. Main. And then I like to do the end, so that I know the end's been done. Because every function has to end with an end like that, otherwise your program won't work. So first things first, let's make sure all the doors are shut. So let's say, so reset the system. Or should we just make sure the main door's shut? No, we should make sure all the doors are shut, shouldn't we? So let's make a function that shuts doors, right? So I'll put it above the main function. So local a function move door, and we'll give this two variables because we need to know which door to shut. So say door, which door, and whether or not we want to open or not. So if we pass true to that, then we want to open it. If we pass false, we want to shut it. So so we say if open. So that means if you just put that like that, if open, then that means if open is true, then else end. So that's all ready for the code. You don't have to write it like this. This is just how I do it. So then maybe we want a better way to pulse Redstone instead of writing it out full every time we want to do it. So maybe we should make a function called pulse rs. and then maybe that function should want to know what side. So we've got output side, haven't we? So that's always going to be the same. So, and then how many times? So that's passed in through door, because here we're going to, I'm going to do move door, and we'll tell it which door. So we'll say, doors again, I can't remember. Code door. So code door. So we'll just pass that in, and we want it to close, don't we? So false. Right. So code door becomes door in the function. So because it's the first argument there, it's the first argument there. So its name is now door. So we call it door. So we say door dot, and then, well, actually, let's start writing pulse rs because it's getting confusing. So local function pulse rs, and then it would be side, and then it would be number of pulses, and then color, I think. Yes, yeah, that's right. So put in that so that we know that the end's ready, and then we say this is going to be a little bit complicated. So we'll say, what we can do is we'll write this function so that if you give it color, it does it through the bundled output. But if you don't give it color, it does it through the set redstone. So we'll say if color. So that means that again, if color is true, then we'll do a loop. So for, you've done these before, for I equals 1, go as far as n, do, and then rs dot set bundle. You've done this. In fact, I've got this over here somewhere, so I'm just going to paste this in because I'm not writing that whole thing in. You guys have seen this before. I'll go through it anyway. So rs dot set bundled output, and then that's the side, and then we add its color using the colors dot combine function to what is already coming out of the same side, like so. So we say rs dot set bundled output to the side we're talking about, get the colours that are already coming out the side, add them, and the colour we want to that side output. So that's easy peasy. And then we'll sleep, and then we'll turn it off. Again, I've already got this over here, so I'll just paste that in. So we sleep, and then we subtract instead of combine. You see? Simple as. And then that is that. That loop is ended. And then, so now we need to do else for that. So again, this is simple. So you guys have seen this 100 times before. There you go. So if color isn't true, if there's no color, then we're assuming it's just the side we want to turn on and off. So rs output side, yes. Sleep for a bit, side, false. Done. Simple. You guys are all getting angry at me for just, ooh, that says all. For teaching you things you already know. So move outputs, we'll say door dot pulses, because that was n. Yep, number of times. And then we want to close. Oh yeah, door dot open, because we've got them up here under door dot open. You see, so we say door dot open. We get door dot open. So in this case, we'd be passing code door. So code door dot open colors dot white goes into pulses. So the color is colors dot white because it's the third argument, and that's what door dot open means, colors dot white, which goes into color, which gets passed in there. Simple times. So pulse rs, not pulse rs, sorry, move door. So that's that. I'll get rid of that space because it's annoying me. And then else. So we do exactly the same thing, except this time we're trying to close the door. End. Good name for that? Oh, I already did all these. I'm rubbish. There we go, so that's that function. So we'll close the code door, and then we'll close the password door. No, passkey door. Is that right? Pass? Oh, it's pass door, isn't it? pressed off. There you go. So Sublime has this really cool feature. If you push Control Space, it opens up suggestions for other things. So if I do Control Space, it suggests other things I've already written. So past door I've already written, that's what I'm looking for. So I'll push Enter, it fills it in for me. Saves time. Brilliant. So after we've shut the doors, let's sleep for a little bit. So let's sleep for like half a second, just to make sure that everything's all caught up and we're ready to go. So now we need to start outputting to the monitor, don't we? So first we need to know where the monitor is. So because we're using output up there, so we've got the output variable. So we'll apply the monitor to an output variable. But first we need to get the output, or get the monitor, don't we? So local function get monitor, and then that doesn't need to take any arguments, does it? So end like so, and then get monitor, that needs to go through all the sides and look for a monitor and only return a monitor. So we'll say, so we'll use a different type of for this time. So we'll say for IV in I pairs, and what that means is so sides do. So what that means is I pairs is a function that will go through the table of sides, which is this here at the top. So that's, first of all, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, because they're in, so 1 to 6. So what this does is it will, every time the loop goes round, we'll start at 1, which will be left, and then the next time it goes round, that will be 2, and that will be right. See? So for that, so now we'll check to see if that side's correct. So if, and then using the Peripherals API, peripheral API, peripheral.getType, at the side we're talking about, so v equals the current side we're talking about, or the current value at I inside. So I would equal 1 the first time around, so that would mean v would equal left, so we just say v. So if it equals monitor, then do something, which in this case would be, we would create a handle for the monitor. So we'd say peripheral dot wrap. So that's what that does, is that returns, as we've already talked about before, that returns the peripheral at the current side, which again is v, because at the moment we're talking about whichever side is indicated by the number of times we've gone through this loop. So close that, and that one is finished. So we'll give it a space, and then we're sorted. So output equals get monitor. So then what else do we need? We need to get the notes, the note block, don't we? Did I make a variable for note? I don't think I did. So do I need to? I think I need to. I think. Yeah, I really do need to, don't I? So we'll make another one underneath output and call it note. So that's the note block that's on top of the computer. So we'll say note equals get note block, and then so for get note block, it's more or less block. Get note block. Get note block. It's pretty much exactly the same as get monitor, except that is note. Now, what we could do is make a universal. Oh, let's change that. Note block. What we could do is make a single function for both of these, couldn't we? We could say get peripheral just by doing this. So we say get peripheral, and then we'll make a variable called type, and then type in there. So then all we need to do, see how that one says monitor and that one says note. All we need to do is call that one there, and then say monitor, and again for that, and then for that we say note, and that would do exactly the same thing, but now instead of having two functions that are almost exactly the same, we've got one. So how cool is that? So now that's going to give us, so we know where the monitor is, which is output, and we know where the note block is, which is note, which means we can do things with those. Now what we need to do is we need to start making the buttons, don't we? How are we going to do that? So I think the best way we're going to make buttons is we're going to make something called, well, it's not technically a class, but it's close enough if you don't look too hard. So to do something like this, you need an object that is an object all by itself. So if that makes any sense. So what we're going to do is we're going to create a box or a button class that can be treated as if it's a button. So what I mean by that is, first, well, what is a button? It's a box, isn't it? It's just on the screen, it'll just be a box. So we'll create a base class called box. So we've got local function, new box, and then when you're making it, you give it width, height, color, and a label to put on it. So that. So first of all, we want to well, let's create a box first. So box equals is a table. So box is an empty table, and then variable box.x equals 0. Actually, we should make it equal 1, shouldn't we? Box.y equals 1. Box.width equals width. So that means the box's width equals variable width. But in case the person running the program doesn't give me a width, we'll just assume that we'll just give it a backup variable value, which is 1. So we'll say box.width is 1, but if box.width is this width, but if width doesn't come in or is false or something like that, we'll give it 1. Oops, excuse me, text message. We'll do the same for height. So copy and paste. Let's just cheat a little bit. There we go. Copy and paste, and then we'll make a way to make the boxes invisible, because that's always cool. So we'll say box.visible is true. So we'll make it true, but if you we'll make it so that if you set that to false, the box won't draw. Box.color equals, can't spell, color equals color or 1. No, wait. Colors dot white. There we go. And then box.label. So box.label equals label. Or space. So, or it's blank. We'll give it a type as well, so that we know what we're talking about. So box.type equals box. There we go. So you're a box. Now, these are all properties because they're inside the box. Oh, hold on. So then we have to return box without the capital. Right. So the way that's going to work, if you can imagine now, if I go down over here and I call, so I say gym equals new box, and then I give it 1, 1 for width and height, and then colors dot brown, and then hello as its label. What that'll do is that will effectively create this. So I'll have a box that is stored in gym. So that box will have a .x, .y, and a width and a height and a color and a label. But it doesn't do anything, there's no way of doing anything. So what we need to do is give it functions inside the object. So we've got gym there. So for example, if we've got width and height is in gym is 1. So I could actually say with gym.width, and gym.width would equal 1. So that would be true. So what we're going to do is we're going to make some functions inside this function. Bear with me. So local function will make a function called invalidate. So what that'll do is if this box is in a display list, so we've got this draw list here, if this is in the draw list, it will change that to true. So that means we know we need to draw it. So that's pretty simple. So end, env, end. So we'll say what? We'll say if I have a parent. Now here's the cool thing. Now in Lua, there's a way to make it talk about. You see how we've got Jim down there. Now normally, if I was going to run this program here, this function invalidate. So if I say we add box dot invalidate equals invalidate, that means now this function invalidate is in box.invalidate, which means over here I could say gym.invalidate and then run it like a function. Now that's pretty cool, but the cool thing, the even cooler thing, is if we go up here and we say, if we add a variable, now generally you call it self, but it has to be it doesn't matter what it's called really, but it has to be the first one. So if you say self, actually I think it does matter what it's called, just call it self, simpler. So we say self there, that means that we're actually talking about whichever function, whichever object invalidate belongs to. So invalidate belongs to this box, which in turn belongs to Jim. So we could say that. So invalidate Jim.invalidate Jim. So that means that then we can talk about Jim inside this function. But a nice little trick is if you get rid of that and then do the colon instead of the dot, that means we're actually talking inherently about Jim and we don't need to pass it in there. So we say validate self. So we say if self dot parent. That's probably where the parents were born. So we'll say box dot parent equals nil. See, it hasn't got a parent. So if it has a parent, so if self dot parent, then self dot parent dot invalid equals true. So that means when Jim gets added to draw list, that would mean that draw list would be its parent. We'll set that up manually. That's not something that you do automatically. And then that means that when I say self.parent, I'm talking about the draw list, so which means it dot invalid is that there, and we make it true. So it means not valid anymore. End. So now from here, if I say when I run that won't do anything because Jim doesn't have a parent yet. But we'll add a function that adds things to the draw list and adds them to gives parents, sorts parents out like that. Very sorry if this is boring, but I did warn you this is code. It's not inherently interesting, or at least it is for me, but not for a lot of other people. So okay, so our boxes are going to need a way to be drawn, aren't they? So let's make another function. We'll call it draw. And that'll need self as well. So that function. So let's do this as well. So box dot draw equals draw. There we go. So again, we can run that through Jim down at the bottom there. So first things first, we don't want to draw it if it's invisible. So if not self dot visible, then return, because we just end that function. We don't want to do anything else. It's over. We don't want to do that. I always return 0. I don't think you have to do that, but I like it anyway because shut up. So first we want to we want to set the computer to be using the right background. So output is that monitor, isn't it? So output dot set background color, and that's my color. So or the box's color, should I say? Color. So now we need to draw each pixel of the box. So if it's got a width of 1 and a height of 1, it's got 1 pixel. If it's got a width of 2 and a height of 1, it's 2 pixels. You know, if it's got a width of 2 and a height of 2, it's 4 pixels. Simple as that. So it's width times height. We've all done maths. So we'll create a temporary variable, hence the local word, local x and local y. Now these don't refer to these box.y because we're not saying self.x or self.y, we're just saying x and y. So create a loop that turns, so we'll start from yeah, so we'll start from its x, self.x, and then we'll go until we've hit width -1, because we already start at 1. We don't need to, if width is 1, we don't want to go an extra 1, so if you take the 1 off, then that's sorted. So, but we'll have to add that to x. So self.x plus self.width -1. Now to make sure that happens in the right order, you just put it in brackets. I don't think you'd have to do that there, but it's easier to read for everybody. So we say do, and then we'll do another loop in this one. So for y equals, and then pretty much the same except with y and height instead of width. Height do, and then we'll set the cursor to to x and y, and then we will input dot right, and then we'll just write blankness on there because at the moment we're just trying to colour the screen, and that's how you colour screen in ComputerCraft. You set the background colour, then you write to that background colour. You write a blank space to that background colour at the position that you want. So then then we need to write the label, don't we? So we'll say if so x. So we've already got x up there. We'll just use it again. So we'll say x equals x plus. Now we don't know how long the label's going to be, and we want it to be in the middle of the box, don't we? So if we were talking about x, that's the top left of the box, technically, isn't it? So we want to talk about the middle of the box and the beginning of the string. So what we'll need to do is say self.width times 0.5. So that just means a half. So it's the same as doing divide by 2, but it's easier for the computer to do. So times by 0.5, exactly the same as divide by 2. It's just quicker and cheaper. So minus, we need to get the length of the label. So we use the function string.len, as in string.length, and we say self.label. And then we need to get the middle of that as well, so we say 0.5. Let's put some brackets in there actually. Yeah, so, okay, we'll do bracket around that, and bracket around that. Oop. There we go. Oh, there we go. And if we do a bracket around that, like so, yeah, there we go. And then, so now here's the problem. What if self.width is 1? We don't want 0.5 as an answer, do we? Or we don't. If it's 3, we don't want 1.5 as an answer, and the same with the string. So we're going to use another function called math.floor, which gets the floor value. So if we've got 1.2, math.floor will change it to 1. If we've got 0.5, math.floor will change it to 0. Perfect. So just wrap that whole thing in that. Sorted. So for y, that's not really a problem, is it? Because we don't need to worry about the height of the label. We only need to worry about the height of the box. So self.y plus math.floor self.height times 0.5. And that one's that. That's that. It's simple. Right. So I keep saying simple. It's not simple. I'm being a dick. So output.setCursor was to x and y, x, y, that we've just set up there, and then we'll write the label. Right. Self.label. See? Self.label. Perfect. Okay, so that's it there, and that is our draw function. So now we just say draw equals draw. It's already right. So now you could easily just say Jim : draw, and that would draw Jim. We don't want to do that yet though, because we don't want Jim to draw himself, because that's dirty. That's how you go blind, drawing yourself like that. Dirty Jim. So we've created a box. So that's pretty cool. But we wanted a button, didn't we? excuse me, that's my knuckle. So we wanted a button, didn't we? So what we probably would be worth doing is we'll create an object that extends the box. So we've got a new box. Let's create local function new button, and then that would need a width, a height, a color when you click on it, so down color, a label, and a value. So that would be the value of the button. So when we click on number 1, that would be value 1. If we click on number 5, that would be value 5. So that's the number that it would add to the combo that we're doing. So first things first with this is that because we've already got this here, new box, we don't want to write all that code again. The whole point of writing that was so that it would save time. So what we say is box, we'll make a new box again, or we could have called it button actually. We'll call it button. Button equals new box, and then we pass these in anyway. So we've already got, I mean look, we've got, let's copy those across so we know what we're talking about. Width, height, color, label. So width, height, color, label, and that's already there. So we've got width, height, color, label. We've already got those. So when someone makes a new button, they already supply those, and we just throw them into the new box and we get a box back. Simple as. So but a couple of things are going to have to change for a button, because it's going to have to draw differently, because it's going to have it has two different versions. It has when it's up, when it's not been clicked on, and when it's down, when it's been clicked on. So we'll need to make a different draw function. So local function draw, self again, obviously, and we'll say, well, what we'll do is we'll create a counter so that it stays down for a certain number of like loops, and then we can do it like that. So self dot down counter is greater than 0, so we'll start. So what we'll say is when it gets clicked on, it adds a number to down counter. Then self, and we'll say down draw. We'll call it down draw. So that's what you do when you, that's how you draw if you've been clicked on. Oh no, wait. So else, that means if we're not drawing that, once we say self up draw. There we go. End. So that's that. So we've already got up draw. Up draw is this. We've already written it. We don't need to do it again. Okay. So what we can do is we'll move those around. So we'll say local function down flipping it down draw self again, and so in this one what we need to do is change. So technically we only need to run up draw, don't we? But we need to change the color. So we'll temporarily, so we'll say local temp color equals self dot color, and then so that's keeping hold of self dot color. And then we say self dot color, equals down color. See, we're tricking up draw into doing our dirty work for us. So we say self up draw. Sneaky, I know, right? And then we'll just put self dot color is temp color. But then we need to self dot, so it's down counter, wasn't it? How was it? Self dot down counter equals self dot down counter minus 1. And then we need to make sure that it invalidates itself. So self invalidate. So that means that it'll remember to draw it again. So what else? So because it's a button, it'll need to know what to do when I click it. It'll need to do something. So we'll say local function click. Self again, because it's a member function or a method. And we'll set down counter when you've clicked. Down counter goes to, let's say 1 for now. So down counter is 1, and then oh yeah, so then you'll also have to return this, the value of the button. So if it's 1, it's 1, as we've already said. So if you push 1 4 times, combo will be 1 1 1 1. So value, so we return value. So if you clicked, you get our value back. Sorted. Okay, so button. So we're talking about the button which we created at the top there. Should probably put a local in front of that. Local button dot down color equals down color, or colors dot blue. I think it's a nice color. Button dot, what was the other one? Oh yeah, so now we need to change the draws around, don't we? So up draw is actually button dot draw, and button dot draw is draw. So that's a bit confusing, but because we've run this, button dot draw is actually this one, the really big one that we wrote before. So we want to move that to up draw, and then we want to make this little tiny draw the new draw for that button. You see? So that's what that does. And let's put down draw in there as well. So button dot down draw equals down draw. Right, so what's the type of this thing? It's a clickable, isn't it? Let's say, because it's a clickable object. So equals clickable. Let's give it a capital C, because why not? Clickable. And then it needs a counter, doesn't it? Button dot down counter equals 0. Button dot value, forgot about that, equals value. And oh yeah, the button the button click needs to go in there, doesn't it? The click function, sorry, equals click. Okay, so now final thing left to do is to return the button, so that down here when I do gem equals new button and then all the variables there, we get gem. We get a button called gem. So got buttons, we can make buttons now. What do we need to do? So we need to make buttons, obviously. So we say button 1, so this is for the button 1, top left hand corner, equals new button, and we'll give it a width of 1, height of 1, colour of blue, and then down colour of red, and then a label of 1, and a value when you pushed of 1. Now I know we could have just used those as the same thing, but sometimes they might be different, so you never know. So, oh, actually, let's say it's x and y. So we'll say button 1.x equals 1, and then button 1.y equals 1. Oh, why did I do that? Equals 1. So that's that. That's the first button created. Now let's create the other ones. So say, so that's 3, 4, 5, 6, 7, 8, 9. I'm not going to do a 0 because there's not enough space on the screen. But so we'll say but 2 like that. Although that needs to go at 3, doesn't it? I think. No, 4. Actually, we shouldn't be starting the top left, should we? 2. That's a 1. 2, 4. Oh, crap. 4, and then 6. Button 3, 3, and then button 4 should go to a new line and start again. So that'd be 2 and then 3. Yeah, and then that should be 5. So button 5, that would be 2. No, that would be 4. That's a 3. 4, 3, and then 6. This bit's a little bit boring, I'm sorry. Button 6 is 1. is 6. That's 9, 6, 3. Button 7. Can you figure out the pattern yet? It's going to be 2, 5. Button 8. It's going to be everywhere. It's going to be 4, 5. Button 9. Final button is going to be 6, 5. Simply simples. Not at all. Right. So now we've got the buttons, but we don't have a way of drawing them or adding them to that draw table. We could just add them there, but that doesn't do anything, does it? So we need a way to add things to the draw list. So that means we need a function. So what we'll do is we'll create another function, move it right to the top. Under those things, because that's, put it there. So local function add to draw list brackets, and then we need the object that we're going to add and what index we're going to add it at. No, we don't really need that, but that's a nice little extra to have. Maybe in the future we'll use that. Lets you put things above other things, so we'll have layers and sort of thing. So if you don't supply I, we'll give you one. So I is I, or if I doesn't exist, we'll just figure it out. So get n, we'll just add it to the end. Draw list plus 1, so we're adding it to the end of draw list. So table dot insert, we'll insert it into the table. Draw list at I, and then it's the object that we're adding. And we need to set the object's parent. Dot parent equals draw list. So that's adding it to the draw list, which means it's visible technically, but should it be clickable as well? Yes, I think it should be. So we need to add something to the click list. So let's also make a function. Add to click list, and then that should again be object. I don't think it needs anything else. It just means it's object. Oh, excuse me. So object and so we say for. So here, what we're going to do is the quickest way of doing this. Instead of saying like, we need to know if I click on say 5x 2y, whether that is an object or not. So the easiest way of doing that is to create a multi-dimensional array. So you know how we've got these tables up here, so we'll create tables within tables, so that x5 y2 would actually be the button that we're talking about. So I'll try to explain as we go along. So we'll say for x is, so we'll start in x, so we say object.x. It's quite similar to how we drew it before, so we say object.x plus, and then in brackets like before, object.width minus 1. Oops. Do. So now we need to make sure that it exists, because we want tables within tables. Now we might not be talking about a table that exists at this point. So object. So we're talking about the click list. So click list x might not exist, so we need to check. So click list x equals, and then we'll say equals itself. Bugger. Which means okay, that's fine. But if that doesn't exist, if that's not real, we make a new table in there. And then we talk about y. So we say y equals, we should make those local. local y equals object blah 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 blah. Just copy paste that. So we say talking about y, and not y, height. Do env, and then at that point in the table, insert click list at x by y. Oh, no, wait, sorry, that's not right. In the x, that's it, by y, we insert object. So that means if x is 2 and y is 5, when I click it and we check in the click list for 2 by 5, it will come up with object, which means we'll know instantly that I've clicked on that object. And it's very cheap to do that way, so that's good. So there we go. That's that. Click list. So that was get draw list, wasn't it? So now we need to add it to the click. So we say if object, was it clickable? I think it was clickable. Dot type equals clickable. Then cat's just jumped on the lap and made me jump. Then add to click list object. End it. And then we need to invalidate list. So draw list dot invalid equals true, because we've just added something to it. We need to invalidate it because we need to draw again. So that's all those done. So now we need to create the I wonder if we need to do that. Okay, so let's make a loop. So first I want to make sure, because there's something in Computer Craft called events, and what they mean is that an event can happen and you can wait for an event to happen before you do anything else. So that could be, for example, in our case, clicking on the screen. But because people griefed with those, because it can stall a server if enough computers are waiting for an event, you actually have to end the you have to stop it from waiting for an event before 10 seconds, otherwise the computer just turns off, which isn't good. So we'll create an event timer, and then we'll make the program loop, which means it's going to keep doing this until the right combo's been entered. So while true, do. Simple as that. End. So while true, first we draw the screen. We haven't got a function for that yet, so I'm going to go write that. So draw a screen. So what we're going to have to do for draw a screen. So this should be fairly simple. I'll put it in a click list. There you go. Local function. Draw screen. We only want to draw it if it's invalid, don't we? So if draw list dot invalid, then make it valid again. We'll do it first, because if we do it last, then the buttons won't do it at the right time. So draw list dot invalid is true. Clear the screen, so we need to clear the screen, so output.clear. And then we say for everything in the list, in the draw list, my pairs, we talked about that one already. Draw list, do, so not actually end there, but do, because we're talking about these objects, do you remember? Remember how we were talking about Jim and we could do the colon? Because all we're talking about, the only thing on these should be buttons. The only thing on the draw list should be buttons. We can actually do the draw like that, because everything that's on the draw list will have a draw function as defined up here. See? So with that in mind, That's all we needed to do for that. So in that loop, I know we already did, didn't we? In that loop, and then that if. So that's that. So we've drawn the screen. So we've drawn the screen. Now, I like to try and clear the events because, as we've said before, events hold the computer up, but they never ever go away unless they get pulled. So the way events work is they go into a big queue, and then you ask for an event. You say, "Is there an event?" And you will wait there until you get an event. So sometimes it's a good idea to just empty the event queue. So you say clear events. So that's a new function we're going to go quickly, right? So to clear events, what we're going to do is say local function clear events, and then what we'll do is we'll put in our own event. We'll put it at the end, so it will know that that's the last event. So we'll say os.q event, call it clear, and then while true do. It's probably a nice way of doing that, but I haven't got time right now. Pull an event, so pull event. Now this is the function that will make the computer freeze. So os.pullEvent will freeze the computer until it gets an event. So now, by this point, we know there's at least one event on the list, which is queueEvent. So we'll say if e equals clear, then break the loop, because we're done, we're finished. But otherwise, you want to just keep going, don't you? So otherwise, it'll just keep going on the loop. And I didn't do an end for that function, which is naughty of me. So we've cleared the event queue, which we've got a nice clean event queue. So now we want to start trying to pull events. So we're going to need another loop for that. So while true do end that loop. There's lots of ends there. End that loop, and then we'll start a timer at event timer. Event timer equals os.start timer for 6 seconds, because that'll be how long it takes for the computer to try and go around again. So 6 seconds, and then we'll pull an event. So local e, local e x what y. So these are all things that come through from a right click on the screen. So you get E, which is the type, side, which is the side of the monitor, the side of the computer that the monitor has been right clicked on is attached to, the X and the Y of the position of the click. So os.pull event. So this means we're going to be waiting for something to happen. Because we've emptied the queue, we know that there's nothing on there, so we're going to be waiting for something to happen. By this point, either this timer is going to happen in 6 seconds time, or the person is going to right click on the screen. So now if we say if E is a monitor touch, so if the event is a monitor touch like that, then so that's a keyword defined on the Computercraft Wikipedia, which is really, like, if you want to do this sort of thing, it's your Bible. So handle, we need a way to handle click, don't we? So we'll say make a function called handle click x and y, and then we'll go and write that. So handle click. So I need to go and do a click. So this should be pretty simple, because function handle click x and y end. Oops. Okay. So we need to know if the object exists. So let's write another function called local function get object at x and y, and what that'll do is that'll look on the click list that we set up earlier to see if there's an object on it. So we'll say if click list space in there. If click list x, then, damn it, then if click list x y, then return click list xy, because we know that click list xy will be the object that's at x and y on the screen, because that's how we set it up. Otherwise, we'll just return false, because there's nothing there. There's nothing at that point, so we'll just return false. So click list object equals get object at x, y. So now, if object exists and object is clickable, type equals clickable, then so combo needs to have the value added to it. So combo equals combo, and then because it's a string, you add two strings together by the double dot. So it's combo dot dot, and then it's okay. So we get the value of click through clicking, don't we? And that tells the button that it's been clicked. So we say click like that. So if I remember correctly, yeah, so that will make the button go down and return its value. So perfect. So click, 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 click. There we go. So combos click, and then we'll add count. Add one to count. So count plus one, and then we'll play a note as well. So note dot play note. It's piano, which is 0, and then button. Is it button push? Yeah, there we go. And then we end that. And then that means that we're going to click the button, and we get a little ding dong. And that happens. Don't be dirty. Don't be dirty. So we've done a click. So a click has happened. We check to see if that click does anything. So now we need to see is the count 4, because that's the number of that's the combo. So then if combo equals the code, that's right, we've won. The game is afoot. So we say sleep. We'll sleep for a second just to let the computer catch up, because we played in notes. We want the next notes to work. Okay, so should we write a little function called play note? In fact, I've already got this, so I'm just gonna copy paste this in. I'll explain what it does. So let's put it there. So play note, and that takes in a table of notes, which we've got up at the top here. So we've got this combo success, combo fail. It's a table of notes. So table of notes for every note. Play a note and wait 0.2 of a second. Simple as that. So sleep for a bit, and then play note. And then this is combo success. So combo success, yes. Combo success. And then we want to open the door. So move door. And that was the code door we want to open. Code door, true. And then we don't need to close the door because we do it up here, don't we? We close the door again up here. So we could just sleep for 5 seconds and then end, because then later on we'll make the computer restart. So end, and we'll set this into the startup program. So monitor is touch. So now what have you done there? That's what happens if the monitor is touch. Hold on, what happens if the code's wrong? I forgot about that. So change that to else. Else if the code's wrong, sleep for a second, like before. Play another note, so we'll play the fail this time. So combo fail. reset everything. Oh no, we don't need to reset anything because we're going to reset the computer. So we'll sleep for 5 seconds anyway, because they got the combo wrong. You get punished if you get the combo wrong. So that's that. That ends, and then let's restart the computer. os.reboot. Okay, so we've got the timer, but we don't need to do anything with the timer, do we? You know, the timer we set up there. We don't need to do anything if that goes off, we just need to go again. So so the timer happens, yeah, we just want to go around again. We don't want to wait anymore. So we say, yeah, so if it has been a monitor touch, we break the loop. We don't want to loop again. And to make sure that we still get the screen drawn during this loop, I guess we could just stick that in there. Couldn't we? Yeah, that'll do the trick, won't it? So, okay, so breaking, and then that's it, I think. Do we need another end yet? That's a line there, so that means we need another end. And then get rid of that. Spaces there. Oh, no, there's the other end. Get rid of those spaces. Spaces make me angry. Okay, so now the last thing left to do, I think, is to run main. Because we've defined it, but we haven't run it. So that's that there, so we've run main. Now, I think we might be ready to go.